Alright, this is an example problem. This is actually homework question number 5, dealing with molarity, mole fraction, and molality. Alright, so I'm going to walk you through step by step how to do this problem. Okay, so the first thing that you want to notice about this question is that I'm asking you to calculate the mole fraction, molarity, and molality. Okay, so there is there are three answers. Okay, there are 3 parts to this one question. It's a large question, okay, but there are 3 parts to it. Alright, so the first thing that I want to do in here, okay, is to list mole fraction, molarity, and molality as what their identities are. Okay, so mole fraction is equal to the moles, okay, the moles of solute divided by the moles of solute plus the moles of solvent. Okay, that's what you need to know about mole fraction. That's literally the definition of mole fraction. Alright, so that's the first thing. The second thing, again, is molarity. Molarity. Okay, and molarity, you should know this, is moles of solute divided by liters of the solution. Okay, so there's a volume of solution there. Alright, so remember that the solution is the solvent and the solute combined makes up the solution. Okay. The next is molality. Molality. Alright, and that is equal, that's another unit of concentration, but it's equal to moles of solute, so that same numerator, moles of solute, and we divide that though by the kilograms of solvent. Okay, so it's different than the solution, we're just dealing with the solvent here. Okay, so we have, wait 1 second, let me move these. Move these over here to the right. Okay, a little bit more. There we go. Okay, so we have these 3 things that we need to find. And the first thing I'm going to do is find the mole fraction, right? And notice that to find the mole fraction, I need to first find moles of solute, and I need to find moles of solvent. Okay, well, I can't find moles of solute or solvent until I know what is my solute and what is my solvent. Okay, so we have two chemicals here. We have NH3, okay, which I'm going to put here. NH3, this is ammonia. Okay, I'm just going to put a colon here just so we can write it out. And the other is, maybe, hopefully you guessed it, the other is water. Okay, so between these two, I have to figure out what is my solute and what is my solvent. Okay, so remember that my solvent is the one that's there in the greatest amount. Okay, and the greatest amount here, you probably see, is that water has 81.3 grams and ammonia only has 30.6. So water is going to end up being my solvent. Therefore, ammonia is my solute. Alright, so that solute and solvent, got it. Alright, and what I'm going to do next is I'm just going to put the values that we have. So we have 30.6 grams of this ammonia, and we have 81.3 grams of water. Alright, the next thing that I'm going to do is to find the molar mass of both ammonia and water. And the reason I need to do that is because I'm looking for, remember, moles, right? And all I have is mass. And the only thing that relates mass to moles is the molar mass, okay, which is always in grams per mole. So I know there's mass there, and I'm trying to get to moles. So molar mass is going to be the perfect thing to use as a conversion factor, the perfect number to use as a conversion factor. All right, so the next part is that I want to figure out the grams per mole, the molar mass, that is, of both ammonia and water. All right, so I've added the periodic table symbols for each of those three elements, the three elements that we're going to need here. So what I'm going to do here in the periodic table, what you do is you go and you look at the formula itself. So I got NH3, and I see that there is one N and three H's in NH3. And then you look on the periodic table and you see that the atomic mass of nitrogen is 14, about 14 for every single one of those nitrogens. So every nitrogen is worth 14, so I write a little 14 under there. And I have 3 times hydrogen, which is 1, about 1. Okay, so if you do the math here, 14 plus 3 times 1, that is 17, and the unit for that is grams per mole. All right, grams per mole. And then I'll do the same thing with water. 1 second, let me erase that. Do the same thing with water. So water, of course, is H2O. So I have 2 H's plus a oxygen. Hydrogen, again, is just about 1, so 2 times 1. And then oxygen is 15.9999, but really it's really close to 16, so we say 16. Add those together, it's 18 grams per mole. Okay, 18 grams per mole. So once I've found that, we're getting close to being done here. So in order to find the moles, okay, if you know mass, okay, and you're trying to get to moles, okay, what you need to do is to divide by the molar mass. Okay, mass divided by molar mass will give you moles, right? Because if you have grams divided by, if molar mass is grams per mole, the grams cancel. You're left with basically 1 over mole to the -1, and then that actually flips over and it becomes just regular old mole. Okay, that's comes from the whole mathematics. If you have 1 over x, this is equal to x to the -1. Okay, or if you have 1 over x to the -1, this is equal to x. So flipping whatever's on the bottom, when you flip it to the top, the exponent changes signs, right? So if you have a 1 to an x to the first, you have 1 to x to the first, but then if you put it into the numerator, it becomes x to the -1. Likewise, if you take this and put it underneath a fraction, okay, and you flip places with it, it becomes 1 divided by x. But don't worry about that too much. Anyway, the only thing you should know, or really need to know here, is that if I want moles, and I am given mass, which I give you mass, and you're trying to find moles, you divide the mass by the molar mass. Okay, so for NH3, we have 30.6 grams, and I divide that by nitrogen's or ammonia's molar mass, which is 17 grams per mole. That is equal to 1.8 moles of NH3. Okay, and that's a good number to keep here, so I'm going to put that over here. I have 1.8 moles of that. All right, don't know what I did there. I just put 1.8 over here. All right, the next is water. So water, H2O, I have 81.3 grams of water divided by 18 grams per mole, which is equal to 4.5 4.52 about moles of water. Okay. I guess if we're being consistent here, we can say that this is actually 4.5. If we want to keep our numbers about the same here, so 4.5 moles of H2O. All right. Next, okay, so we have the moles. Now we need to do mole fraction. All right, so remember that the mole fraction here is equal to the moles of the solute divided by, or I'm really looking at this part right here, right? This part right here. Don't need to erase this part. Okay, so what we're looking at here is the moles of solute divided by moles of solute plus moles of solvent. Okay, and we already said that NH3 is our solute and H2O is our solvent. I need to add what the moles are, so here we got 4.5 moles. Right. Okay, so the next thing we're going to do is we have our moles of solute. We've discovered that is 1.8 moles. Okay, and I'm going to divide that number by 1.8 moles plus the moles of solvent, which is 4.5 moles. All right, that number is 0.286. And there is no unit because it is a fraction. All right, and this answer finally is the mole fraction. Okay, so the steps here are: 1, figure out what is your solute, what is your solvent, all right? Then you want to find out how many moles of each you have, right? How many moles of each that you have. There is no, again, there is no units here. Anyway, sorry, find the moles, okay? Find the moles of each. And then you're able to say, okay, I have the moles of my solute, and divide that moles of solute plus moles of solvent, and you get a number. Okay, so you need a periodic table for this, but other than that, it should be pretty straightforward. Okay. All right, so the next part of this is I'm going to find the molarity of this solution. All right, so the first thing I'm going to do is create a little barrier here, just so that we know that we're a different part of this problem, okay? But we're going to still be using kind of the same thing, all right? But down here, we're going to find molarity. And remember that molarity is moles per liter, okay? And that equals capital M with a little line underneath it. All right, so moles of solute divided by liters of solution. Okay, so the first thing we need to know about molarity, if we want to find the molarity, well, we know the moles of the solute already, right? The solute moles is 1.8. We already figured that out, right? So we know that it's going to be 1.8 divided by the liters that the solution is. Okay, that'll give us the molarity. 1.8 divided by liters. And in order to find the liters, what we're going to need is the density of this solution, okay? And the reason we're going to need the density is we can use density, which is grams per mil, okay? And we know grams, we're given grams, and then we can use that to convert to mil, or milliliters, okay? So the density for this particular solution, the problem says, is 0.982. So 0.982 grams per milliliter. All right, and we already know that we have how much of the solution? How much does it weigh? Well, our solute, right? Our solute weighs 30.6 grams, and our solvent weighs 81.3. When you add them together, that makes the solution. Okay, so the solution itself is 30.6 grams plus 81.3 grams. This is equal to 111.9 grams. Next thing I'm going to do is divide this number, 111.9 grams divided by the density, 0.982 grams per milliliter. This will give us our milliliters. This is about 114 milliliters. Okay? Now remember though, molarity is in moles per liter, so I want to change this to liters. Okay, so 114 milliliters is the same as 0.114 liters. And the way I get that is I could do that. You can do it like this. If I have 114 milliliters and I'm trying to convert that to liters, that is 114 basically divided by 1,000, because it's 1,000 milliliters per 1 liter. Okay, so milliliters would cancel, and you would have 114 divided by 1,000, which will be 0.114. All right, I'm going to erase that real quick. Okay, so I have that many. So I have 1.8 moles of NH3 divided by the volume of the solution, which is 0.114 liters, and that answer, I'm just going to write it down below it, is 15.79 molar. Okay, so that is the final answer. Okay, to that. So this is answer number 2. Okay, the next thing I'm going to do, I'm going to scroll down a little bit, and I'm going to say, I'm going to block this off because this, now we're going to be talking about the molality here. Okay, so again, molality is equal to moles of NH3, in this case our solute, divided by kilograms of H2O, basically our solvent. We know moles of NH3, this is just equal to 1.8 moles. Alright, we've had that for some time now, 1.8 moles of NH3 divided by the kilograms of solvent. So how many grams, so we want kilograms of water, right? But we have grams of water, right? So we want to go from grams to kilograms. And to go from grams to kilograms, how many grams do we have? We have 81.3, right? 81.3 grams. Convert that to kilograms. The way you do that is by moving the decimal place 3 places to the left, and you get 0.0813 kilograms. That goes in our new denominator, so 0.0813 kilograms of H2O. And then you just answer this. 22, write it down here, 22.14 molal, not molar, but molal, moles per kilogram. All right, so hopefully that is enough to help you work your way through this problem.